Hello, and welcome back to episode 2 of our comprehensive Spring Boot tutorial series. If you've successfully completed episode 1, you should have a basic Spring Boot application running and understand the project structure. Today, we are diving into one of the most fundamental concepts in Spring Framework, inversion of control, or the IoC. Now, this concept is absolutely critical to understand because it's the foundation upon which the entire Spring Framework is built. Many developers jump straight into Spring Boot annotations without truly understanding IoC, which leads to confusion later on. By the end of this episode, you will have a crystal clear understanding of IoC and you'll see how it makes your code more flexible, testable, and maintainable. What will you learn today? You'll master the core concept of inversion of control and why it is revolutionary. You'll understand the Spring IoC container and how it manages your objects. You'll learn about Spring lifecycle and management in Spring. You'll grasp why IoC is fundamental to everything in Spring Framework. You will see real-world analogies that make IoC concepts crystal clear. And you work hands-on with application context and bean management. And you'll build a practical application that demonstrates IoC principles with multiple beans. Now, this episode directly builds on episode 1. So make sure you have your development environment ready and understand basic Spring Boot project structure. Now, what is inversion of control? Let me start with a simple analogy that will make IoC crystal clear. Imagine you are organizing a dinner party. So for the traditional way, you personally go shopping for ingredients. You cook every dish yourself, you serve each guest individually, and then you wash all the dishes after. But for the IoC approach, you hire a catering service, the IoC container. You tell them what type of dinner you want, the configuration. The caterers handle shopping, cooking, serving, and cleanup. You only have to focus on enjoying time with your guests. That's the business logic. So this is exactly what IoC does in software development. It inverts the control of object creation and management from your code to a container. So let's look at the traditional object creation versus the IoC. Now, this is an example of the traditional way where you have your fields, your services declared, and then in the constructor, you instantiate it. Now, this way of doing it has problems. So one of the problems is tight coupling. The other service is directly dependent on specific implementations. Then it is hard to test. You cannot easily mock the dependencies. Then it is inflexible. Changing the email provider in our case here requires code changes. Then violation of single responsibility. Class creates and uses the objects. Now let's look at the IoC way. So with the IoC way, the container provides dependencies for you to instantiate with your service classes. So benefits of IoC, the loose coupling. So depends on abstractions and not the concrete classes. Easy testing. Dependencies can be easily mocked. Then flexible. Can change implementations without code changes. Then single responsibility. The classes focus only on the business logic. The Spring IoC container. The Spring IoC container is like a smart factory. That one creates objects. It instantiates your classes as needed. It manages dependency, wires objects together automatically. It controls lifecycle, manages objects creation and destruction, and then handles configuration. So it uses your configuration to make decisions. Now there are two main container types. We have the bean factory. So this is the basic container with lazy loading. And then we have the application context container. This is an advanced container with additional features, and this is mostly preferred. So let's look at the bean lifecycle in Spring. So understanding the bean lifecycle is crucial because 1, looking at instantiation, the container will create the bean instance, then dependency injection, then the container injects the required dependencies. Initialization, the custom initialization methods are called. then ready for use. The bin is available for use, and then after it has been used, cleanup methods called when container shuts down, so it destroys the bin. Now, why is IoC fundamental to Spring? 1. IoC enables all the powerful features you will learn in this series. So, dependency injection, where we automatically wire or inject our dependencies. Aspect-oriented programming, which is the cross-cutting concerns of Spring. Transaction management, declarative transactions. Security, authentication and authorization of our Spring application. Testing, where we easily mock and test context. So at this point, we'll jump right into our application and write some codes. So now we will build a practical application that demonstrates IoC principles. We will create a notification system with multiple services. So I've taken the liberty of creating our project and setting it up. Let's look at the pom.xml. And then in here, you can see the only dependency I selected was the web dependency. And then the test dependency was automatically added. So first things first, let's create a domain model. So our domain model will be a user model. So to create that, we go here, we go to new, and then so first we should create a package called model. So you can create a package here by clicking on package, or you can go to Java and then type the package name, which is model, then dot the actual class name, which is user. And as you can see, our model package is created with our user. So let's define some fields. So we have private long ID, private string name, private string email, and then private string phone number. So these are our fields. We'll create a constructor. So we can do this by typing. So we can do this by typing, or we can auto generate our constructor. We just right click, then we go to generate or alt insert here, then we click on constructor, then we select all, then we click OK. So for the first one, you select none and then to create the empty constructor. But this one we want all the fields, so click OK, and then as you can see, our constructor has been generated for us. So the same way, we need getters and setters. So we can open that, and then we go here, we get getter and setter. So we click here, we select all, so we need all that, and then click OK. So we get our getters and setters, and then I'll add to string method the same way. So at this time we go to override methods, then I'll select to string, click OK. So what we want to return here is then user ID equals plus the name equals name, then email equals email. So we have this. So our user class is complete. Now let's move on to creating the service interface and its various implementations. So the first thing we need is a notification service. So like we did the first time, service dot noti. Make sure there's no space between them. Notification service. And mind you, this is an interface. So let's pick questions interface. So we get this I symbol. Now let's write the implementation. So void send welcome notification. And it takes a user. Then let's import. So mind you, choose the correct user, which is this. Then the next one is string get notification type. So this is our interface. Then we'll move on to its implementation. So the first implementation, the email implementation. So in the service, let's create a class. So we name it email notification service. Now this notification will implement the notification service. So we get this red line telling us that there are methods to implement. So you see, it says class email notification service must either be declared abstract or implement abstract method welcome notification in notification service. So we just click on this implement methods, then you select both and then click OK. So now let's give the implementation. So all we need to do is we just want to give the welcome notification. So system.out.println, then sending email welcome notification to, then we get the username user.get email, then the subject welcome to our platform, then user dot get name. Yep. Then the actual content, email content is thank you for joining us. So our implementation for send welcome notification is done. Now to the get notification type. So this is an email notification, so we just return email and then we are done for that implementation. So the next notification implementation we'll work on is the SMS notification. So in the same service class, in the same service package, we create the SMS notification service. So this will also implement notification service, and then as always we implement method, click OK, and then there we have it. So let's make this implementation as well. So this is also basically some strings as well. Sending SMS welcome notification to the user.get phone number, then SMS welcome user.get name. Thanks for joining our platform. Then we go to the string, to the notification type, and then this is an SMS, so we just type SMS. So our implementation here is done. So now we want to create a user service, to make use of these notifications and to demonstrate the IoC concept. So in the same service package, another service, this time name it user service. Let's define the field. So private final notification service, and private final, then a list of users, then users, and equal to new array list, then private final atomic long, then ID generator, and equal to new atomic long. Let's create our dependency. Let's create our constructor to inject our dependencies. So click on constructor. So in this, we need only the notification service. Then you click on this. Okay, so we have our constructor. So with this constructor, we'll annotate it at auto, and then we'll give here at qualifier. Then we give the name email notification. Now we are getting this. For now, don't worry about this at qualifier. We'll look at that in subsequent tutorials. So we are getting this error because we've not told Spring that this class is a service class. So we use at service annotation, and then the error is gone. But then we have another error here. So in our previous service classes, we also didn't give that service annotation. So in the SMS, you go up here and then you do this at service, and then here you give it a name, SMS notification, and then in here you do the same here for email at service, and then email notification. So when we go back to our user class, you say that our error here is gone. Alright, so let's continue. Then in here, I want to just give out a statement here. So user service created with notification service dot get notification type, and then write notification. Yeah. So let's continue with implementation. So now we need to be able to create a user to get notification. So public user, and then create user. Then this takes string name, then string email, then string phone number. So let's define an object, user object, then ID generate will give us the ID automatically. Increment. So this will get an increment. So this will create an ID for us, and each time a new one is created to increment it. So name, then email, then phone number. So now let's add the users to the array list. Yeah. So and print it out. User created. So now let's send a welcome notification using injected service. So using the injected service. So in our case, when we do this notification service dot send welcome, and then user. Now it says you should send a welcome notification using the injected service. Now in here, our injected service is the email notification because of this at qualifier. So this at qualifier is telling the Spring Boot that the notification implementation we want is the email notification. Okay, I hope that's clear. So now we'll return the user. So now let's move on to other methods. So public a list, we want a list of users, then get all users. So return a new array list of users, and then we want to get user by ID. So public user get user by ID. So this is a long ID. So return users dot stream, and then we'll filter. So user dot get ID, and then dot equals ID, and then dot find first, and dot or else now. So this will get the users list, and then to filter by the ID, which is equal to the ID given here, and then to find the first one. And if it doesn't find it, it will return null. Alright, so application is coming up well. So now it's time to create a REST controller, and then we implement the endpoints, and then we'll run our application and see how far it goes. So let's create our controller package. So in your controller dot user controller. Alright, so the first thing we do, we give our annotation. We annotate this with at REST controller. Then we'll use this at request mapping API/users. Alright, this will provide the base URL for our application. So whenever you are typing, you just type localhost 8080/API/users, and then the other endpoints will follow. So the first thing we do is to get our user service, because we'll be using the user service here. So private final user service. Now we are getting the error because we need to inject it into our constructor. So as always, let me go to constructor. You see, we are getting a lot here than we did in the other classes. So this is happening because of this at REST controller. So this is Spring or IntelliJ is trying to help us with this. So we'll click constructor, then we select the user service. Okay. Then we annotate this with at autowired. And then in here, let's print out user controller created with user service. So it's best to do this so that we can look at every instantiation or creation of objects in your application as it runs. So our first method, our first endpoint will be to create the user. So to do that, we write this method public response entity user create user. So response entity is a Spring class that wraps your response in a full HTTP packet with the response body and then the header. Alright, so this takes the parameter user request, then request. So we've not yet created this request class, so we will do this at request body. So like I said, the entity will wrap your response in the packet with this at request body. So this is the body we are requesting. So let's create this class. So let's create this in our model. So mind you, this is a simple DTO class for request body. Now DTO stands for data transfer object. So private string name, email, and then private string phone number. Now let's generate our getters and setters. Alright, so this class is complete now. So we go back to our controller and you see the error is gone. Okay, let's continue. So let's define our user. Then use user service to create it, because you have a method there, create user. Yeah. So this will get the request dot get name, comma request dot get email, and then request dot get phone number. So this will give us the user, and then we'll return response entity .ok and user. So if you want to learn more about response entity, I have a video in my channel talking about response entity, so I'll leave it in the description below. And then so up here in the right corner you'll see the video popping up. Alright, so we are done with our method, but then we are not done. So to make this an endpoint, we need to annotate this with at post mapping, because we are creating something, so we need the post mapping. Alright, so our next method will be to get all the users. So public response entity, so this will take a list of users, get all users, then to return response entity dot ok, then user service dot get all users. Okay, so this method is also done. We just annotate this with at get mapping. Yeah, and then we need to get the users by ID. So public response entity dot user get user by ID, and then long ID. Now we want to get the user by the ID, so at path we add the at path variable to this to tell our Spring that this will be included in our URL. So for this, we define the user equal to user service dot get by ID. Now we check if the user is not equal to null. So if the user exists, then we return response entity dot ok user. But then if the user doesn't exist, then we return response entity dot not found new build. Then up here too, we'll give annotation at get mapping, and then this time, because we need the ID, so we add the ID to the path, so slash then ID. This is how you do it. Alright, so our controller is finally right. So let's open our main application file, so IoC demo application. So in here, let's add a statement here to log. So let's say starting IoC demo application. Alright, so let's run the application and see how it works. So we get our build, and then observe the console output. So we have starting IoC demo application as we wrote in our IoC demo application file. And then in here you get user service created with email notification, and then user controller created with user service. So now we will test the application by creating a user. So we use an application called Postman to test our application, and I have a video of how to use Postman in my channel. The link in the description below and then up here. So to use this, we click here, and now we are testing creating a user. So we choose post, then we enter the URL http localhost 8080 and then /API/users. Then in here you choose the body, and then we go to raw, and then we change this text into JSON. Then now let's add our data. So name, so John Doe, comma, then email john@example.com, and then phone number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is our request, and to send this you click on send. Yeah, and so we get our data, ID1 John Doe, and then example. So you see our ID has been automatically generated for us. Now going back to our Java ID, we look through the console output, and then we get this user created. So this is the toString user implementation we give. So we have the ID, name, and then the email. We didn't add the phone number, if you can remember. Then sending email welcome notification to then john@example.com. Then welcome to, so it looks like we have a typo here. Welcome to our platform, John Doe. Then email content. Thank you for joining us. So let me correct that typo here. So that will be the email service. Alright. So now I'll stop the application because, well, our application works so far. So we'll later on test the getting the all users and then user by ID. But I want to show you something. So let's create a configuration class to demonstrate the application context. So we've looked at the bin container. So now let's look at the application context. So in our application, let's create a Java class. We name it IoC container demo. Alright, so we've created our IoC container demo. This container implements the command line runner. So let's implement method. Yeah, so the only method here is the run method. So let's define our field, private application context. And then we choose application context from Spring Framework.context, not the Apache Catalina.com. Then we annotate this with @AutoWired. And then we give the annotation at component to fix the AutoWire error. So get this. So it says field injection is not recommended. So we'll talk about that in a later video as well. So let's implement our run method. Okay. Then we will do this IoC container demonstration. So now we'll show all bins of notification type. So string of an array of string, then bin name, then application context dot get bin name for type, then notification service.class. So let's log it out. So we write found bin name dot length notification service bins. Now let's look through our bin names. So for string bin names, from bin names, then notification service equals application context dot get bin name, comma, notification service.class, then log out. The bin name, service.get class.get simple name. So we are done with the for loop. And then So we'll show total number of beans we had. So system.out print line. So total beans in container. So application context dot get beans definition count, and then let's just add this to. It looks like we defined two application contexts. So let me remove the first one. Alright. So now let's run the application and then let's see what is going on. Okay, so we see our first log statement starting IoC demo application. Then we come down here, we get user service created with email notification, and then user controller created with user service, and we get this information about the IoC container. So we found two notification service beans. So you have the email notification and then the SMS notification. So there are a total of 169 beans in our application. Okay, so let's test our application once again. Yeah, so the same data, we'll send it again. Then we get this information, and you see we get a 200 status code, which means our application works. So now let's get all users. So we go to get and then HTTP. So we can select the same URL and then we just click send. So as you can see, we get the data from our application. We get this. So if I were to add a different user, so let's say Jane. So for every John Doe, there is a Jane Doe. So, and then let me reverse this 0987654321, and then let me send. Okay, so when we go to the get and then I click on the get, you see we have two data here, ID1 and then ID2. Yeah, so now we'll test the get user by ID. So in the get request, then we add /2, and if I send, we get this Jane Doe. If I change this to 1, we get John Doe. But if I do this 3, you see we get nothing, and we get 404 not found. So our user does not exist. That user of ID3 does not exist. So back to our ID, we get this. So we have the user John Doe and then you have the user Jane Doe. Okay. So excellent work. We have successfully mastered the fundamental concept of inversion of control. So let's look up what we accomplished today. So we understood IoC principles with real-world analogies. We built a practical application demonstrating IoC concepts. We created multiple service implementations with dependency injection. We learned about application context and then bean management. We saw how IoC makes code loosely coupled and testable. We observed bean lifecycle and then container behavior. Now, key concepts mastered. So we mastered inversion of control principles. So the container controls object creation and management. We mastered Spring IoC container. Application context manages bean and then dependencies. Then we mastered bean lifecycle, how instantiation, dependency injection, initialization, and destruction works. We mastered loose coupling, how services depend on abstractions and not the concrete implementations. Then we mastered a bit of dependency injection. Container provides required dependencies automatically. We'll look at dependency injections in our next episode, episode 3. So stay tuned. Now, why does this matter? So now your code is now more flexible and maintainable. So it is easy to swap implementations without code changes. Then unit testing becomes straightforward with mock objects. The foundation for all advanced Spring features has been laid. In episode 3, we will dive into dependency injection patterns. So we will learn the differences between constructor, setter, and then field injections. We will master the auto-wired annotation and understand best practices that will make your code even more robust and maintainable. So remember, the IoC is the foundation of everything in Spring. So master this concept and the rest of the framework will make perfect sense. Now, after every episode, I will place a practical exercise in the description. So do well to check that and then try your hands on it. And then on Fridays, I'll upload a video demonstrating the practical exercise. So I hope this will help us, and then if you take it serious, it will also help you. So now, leave your questions in the comment section and let's try to answer them together. Don't forget to like, share, and subscribe to this channel. Happy coding, and I will see you in episode 3.